Hi guys, just an overview of chapter 9, minerals and ores, and just in case you weren't there, you can hear like what we talked about in class. So section 9A, and feel free to follow along with your notes and your book. So describing minerals. We discussed Napoleon III of France and how he honored his guests by letting them eat off aluminum plates. And the rest of the guests, or not like the rest of the staff would eat off of gold plates. So you can think that, well, that might be kind of strange, like that he would let them eat off aluminum and not gold. But in those days, aluminum was more expensive than gold or platinum. And then a few decades later, aluminum is super cheap. So think of like your Coke cans or any pop can is made from aluminum, and how inexpensive it is to buy those. And here you can see some plates that were rimmed with gold. Here's a picture of Napoleon III in his sitting room. We can see all that gold plating that we get to talk about later on in the chapter, and then his dining room. Very elaborate. 9.1 Minerals, Ores, and Dominion. So, aluminum is a metal that is light, strong, rust resistant. You can think of other things that are made with aluminum, so like foil that you would use to bake with in your kitchen, bike frames, ladders, golf clubs. Even car rims are made from aluminum. It's a common metal worth more per ounce than gold before scientists found a practical means of extracting it from ore. 9.2 is defining minerals and ores. A mineral is defined as a naturally occurring inorganic crystalline solid having a definite chemical composition. So a mineral is not man-made, organic, air, liquid water, or a natural gas. Minerals do include, though, natural gold, natural gems, asbestos, and quartz. So we can see right here the gold, and then our gems, asbestos, and then the quartz. Look how pretty that is. Moving on, this is mineral cinnabar that we'll talk about in just a second. So ores are the rocks that contain certain valuable minerals. Ores are also rocks that contain one or more minerals that are a source of elements or compounds that's important to industry or agriculture. So, like I said, this is mineral cinnabar. It's also called mercury sulfide, and it's an important source of ore of mercury. Moving on to 9.3, the origin of minerals. So who created them? Well, God did, of course. We know that. But however, some did not appear in the same forms at the beginning of time. In Genesis, if you're looking in your Bible, it states that gold, bdellium, onyx, and copper and iron are all listed. But after the flood, the Bible mentions at least 36 more rocks and minerals. And the flood completely transformed the Earth's surface, and by doing so, it broke down that original material and then changed it both physically and chemically. 9.4 Minerals and Matter. We read this section, so feel free to reread it or look over it. A mineral composed of more than one chemical element, will be classified as a compound mineral. So we talked about quartz, and I told you it was like that really pretty picture on the back slide. So that is two different elements. So we have Si and O2, so two different ones, and it makes up quartz. Or we have calcite, which is three different ones, and it's making up a compound mineral. So think of compound word, you're taking two words and putting it together, same kind of concept with your mineral. A mixture is of two or more substances combined but not chemically bonded. And then all native minerals are pure elements. So in other words, native mineral is a mineral with only one kind of atom. So in class we talked about how platinum is, copper, diamond, gold, and silver. So those are only one kind of element. So that would be our native mineral. An example was sulfur is to native mineral as quartz is to compound mineral, because sulfur is a native mineral and then quartz is a compound. This is a YouTube video that I just want you to watch later. You can get the link from the Google Slides. 9B was identifying minerals, and then section 9.5 mineralogy. That's a mistype. I'm so sorry about that. Mineralogists are professionals who their job is to study and identify the minerals. They're looking at our chemical and physical properties that make up the mineral. The differences between a rock and a mineral. So rocks we define as a mixture of two or more minerals. However, there are a few rocks that occur as pure minerals, such as limestone, which is calcium carbonate. And then the term mineral is most useful as a chemical classification, and it applies to distinct crystals. When a mineral appears as a massive formation without the distinct crystal, it's considered a rock. So here we can tell, like, if it doesn't have that distinct crystal formation, that we do know that it's a rock. Getting into carat a little bit. So gold, it's extremely soft. 1 ounce of gold can be rolled out to an area over 325 feet. For that reason, gold leaf is used in many decorative applications. The gold leaf process, so here's another little YouTube video that I want you to watch. And it shows you how like they roll it so thin and then they put it over a lot of things and it makes it look like it has like that gold, like very pretty, like Napoleon III's dining room and sitting room. So gold softness makes pure gold unsuitable for jewelry. So that's why it's usually alloyed with a harder metal when it's used for that purpose. A carat is a measure of a mineral's purity. So outside the US and Canada, the spelling is carat like that with a C. Just to continue on. So the number of carats of a substance is 24 times the ratio of the mass of a pure substance to the mass of a sample. So we can think of pure gold as 24 carats since the ratio would equal 1. And you can think of that like when you go to the store, it's 24 karat gold. It's pretty expensive. Some misconceptions about carat and carat. So here we have carat with a K, it's used for purity, whereas carat with a C is a unit of mass. Some metals would be described with carat, such as 24 karat gold, which would be pure gold, which I kind of touched on just a second ago. And diamonds and other gemstones would be weighted in carats. So if they say that lady has a 3 carat diamond ring, that means she has a like massive diamond. So you better be checking it out. Just kidding. Oh, I guess I put it down in here. So for example, a 2 carat diamond would have a mass of 0.4 grams. So you kind of get like an idea of what it weighs. 9.6 physical properties. So we have 7 groups for properties. And with that, mineralogists have to be confident that they have identified a mineral correctly, and they have to use more than a single test to be able to do that, to see if they identified it right. So our first grouping is color. So some minerals have more than one color. And then streak, and that's what I'm showing you in this picture right here. So the color of a mineral's powder is called its streak, and this is what you see. So what they've done is they've taken that mineral and they've taken on a streak plate, and then they see what color the powder produces. Some minerals are too hard to leave a streak on a streak plate, so some of it won't work for. And a more reliable identification property than simply a mineral's color is its streak. So a mineral streak test, so this is another little YouTube video I just want you to watch, and you can see like them demonstrating it. Alright, a mineral streak can be different than its color. So impurities, which absorb particular wavelengths of light, can alter the color of a mineral. So imperfections of the crystalline structure can also change. Then we're moving on to luster. So with luster is the amount and the quality of light reflected from a mineral surface is called its luster. So here we can see 2 different ones, metallic and non-metallic, and they can have either one of these lusters. Metallic luster would be like gold, silver, copper, or non-metallic. Determining non-metallic luster is more challenging. They would categorize non-metallic luster on the appearance of the sample. And then we can have all these other different lusters. So pearly, silky, greasy, earthy, all of that are all the different types of lusters. But your 2 main ones would be metallic and non-metallic. Then the next grouping is the crystal shape and growth. So Pliny, the Roman philosopher, was one of the first people to describe mineral crystals, and that's a picture of him right there. And you can actually see some of the crystals right here in his picture. He noted that mineral crystals come in many fascinating shapes. When crystals have room, they build a shape in the arrangement of the atoms, and that's what you're seeing here. And the process by which a crystal grows is called accretion. A mineral's crystal classification deals mostly with its shape. Cleavage and fracture. So the ways that minerals break helps mineralogists identify them. So minerals break in two different ways, and that would be by cleavage, and then that's when it splits into flat sheets along certain planes, and then fracture, which breaks into uneven surfaces. And mineralogists have 5 ratings for mineral cleavage. So they would rate it as perfect, good, fair, poor, or none. So at the end of the scale are the minerals such as mica, which separates easily into thin sheets, so that would show perfect cleavage. And then at the other end of the scale are minerals such as quartz that would shatter, so they would not cleave at all, so they would have none. Then fracture property, many are uneven, it's a rough surface, it has hackly, it's fine points, fibrous or glassy clamshell, and kind of like chips is when it's breaking. The next one is on hardness. So some minerals are so soft that you can scratch them with your fingernail. Others are so hard that nothing can scratch them at all. And in 1822, Frederick Mohs, a German mineralogist, he discovered a scale that used to classify and identify minerals by their hardness. The Mohs scale is a measure of the mineral's hardness, and it ranges from 1, which is very soft, to 10, which is very hard. Our next one of the properties will be specific gravity. So specific gravity is the ratio of a mineral's density to water density. So we're putting it in water and we're seeing like how dense it is. So determining the density of a mineral sample requires finding its mass and its volume. 9.7 touched on special properties, and we have flame test, which mineralogists use a flame test to identify some minerals. And this YouTube video on flame test is really good. It shows you really like what they're looking for and what minerals burn different ways. So definitely check that out. We read a paragraph under that section too. And then what minerals turn the flame colors. Oops, my slide thing is covering, but sodium, potassium, and calcium. So those are going to show you those 3 colors. That was weird, but specific gravity, the ratio of the mineral's density. I guess it's going to do this now. So we'll watch them spin for a second. Sorry, y'all. All right, on to acid test. So you would use this test if you're trying to identify minerals in families such as carbonates, sulfides, sulfites, and when conducting an acid test, you would place a drop of hydrochloric acid onto the mineral, and if they fizz and give off gas bubbles, you know you have a mineral. And then magnetism. So we would test to see if the magnet would attract a mineral or its powder, and you would